Welcome everyone to this video. Uh, we are going to discuss a question on the chapter of ray optics from the book P.M. Sharma. Question being, we have a surface of fluid of refractive index mu. Inside this medium, we have placed a source of light, point source of light at a depth h below the surface of water. Question is, as light starts to go outside of this medium, it traverses through the medium and it gets refracted at some different angles. So we are asked that it would form some kind of cone like this as the light is going outside. So what fraction of light is actually going outside and what fraction of light is getting reflected inside? So the fraction of light which is going outside, we can know if we know this particular angle theta, and depending upon that we would say that uh, what fraction of light is actually going outside. So and also we it would be very helpful if we know some kind of integrations beforehand. For example, in this cone or in this hemisphere, if we know what is the surface area of this hemisphere in terms of this distance y and the radius of the sphere r, then it would be great. So this area is known to us as 2 pi ry. So we know that some part of the rays will go outside, some part of the rays get refracted. The part of the rays which get just internally reflected, they are part of TIR. So this angle theta is called is the critical angle theta c. So we know that sine theta c critical is 1 by mu. That is what we know. Now, uh, from this we want to find what is cos theta. So cos theta of the critical angle is equal to 1 minus 1 upon mu square and square root. So if we uh, take r, what is the value of r or h, the height h? So that would be r cos theta. So it would be r under root 1 minus 1 upon mu square. Then we'll say, okay, what is the value of r? Or yes, now what is the value of y? So y is nothing but r minus h. As you can see from this figure, this is the radius of the sphere. So this is r and this also is r. So r minus this particular height, this would give me the difference of the height y. So r minus h is y. So r minus r under root 1 minus 1 by mu square. This is the distance y. Then we don't want to know what is the fraction. What fraction of area is uh, or what fraction of light is going outside. So it is the area of the gap, that is 2 pi r by divided by the total height, that is 4 pi r square. So this f is nothing but y upon 2r. Y we already know is r 1 minus under root 1 minus 1 by mu square, and we divide this by 2r. So this is the fraction of the light which is escaping the surface of the medium whose refractive index is mu. So thank you for joining and have a good day.